The significant digits of a measurement are the digits that relate to its precision. Precision is another way of saying accuracy. One of the reasons why we don't learn about significant digits in math is because in math we don't use measurements as our number. In science, all of our numbers come from measurements that we could have gotten in an experiment. So significant digits are all about measurements and their precision. There's no such thing as a perfectly accurate measurement because all our measurements are limited to the measuring devices we have. For example, if I wanted to measure a book, and I used a ruler, to measure it, if my ruler only was divided into centimeter segments, I would get a slightly different measurement than if I had used a different ruler divided into millimeter segments. With the centimeter ruler, I probably could have only gotten a number with 2 decimal places. I could have found out the book was 0.54 meters, for example. With the millimeter ruler, I could have found out a little bit further into the millimeter position. So instead of finding only 2 decimal places, I could have found 3. This answer, 0.543, is more precise. And therefore it has more significant digits. Because the numbers that we measure in experiments lack perfect precision, because we'll never be able to make a ruler that goes as far as micrometers, for example, we use these numbers in our mathematical equations, the significant digits that we have do affect our results. The significant digits from our measurements affect how we round our answers. To get to the rounding rules, first you have to know how to count the sigdigs in a measurement. To do this, you find the first non-zero digit and count it and all that follow. For example, the number 0.0100 has 3 significant digits. You find the first number in the digit in the number that's not a 0 and count it and all the ones that follow, which is 3 significant digits. 0.00025 has 2 sigdigs because we find the first non-zero number and count it and the one that follows. The number 10.0 has 3 significant digits because the first number is not 0, so we count it and all the ones that follow. The rounding rule for significant digits goes like this. You count the sigdigs in the numbers given by the problem and round the answer to have the fewest amount. For example, in the calculation, 108.52 divided by 20, the answer given like a calculator, 5.426, has a few too many digits. And then if we look at the numbers that we started with, 108.52 has 5 significant digits. 20 only has 2. We must round our answer to have the fewest amount of significant digits. 2 is fewer than 5. So my answer should only have 2 digits. That means all but the first 2 have to be gotten rid of. Here's another example. If I do 21.0 divided by 2.0, my calculator gives me the answer 10.5. But since 2.0 only has 2 sigdigs, 21.0 has 3, my answer can only have 2 sigdigs, only the first 2. So the extra digit has to go away, but since this digit is 5 or greater, it bumps the one in front of it up. So 10.5 rounds to 11.